What's the domain? All real numbers. Any exceptions? What does that mean for vertical asymptotes? Horizontal asymptote. It's not clear enough. Y-intercept. So you said the y-intercept was what again? 0, comma, negative 9/2? Oh, positive 9/2. Which is 4.5. 1, 2, 3, 4.5. Yeah? 10. X-intercepts. Set the numerator equal to 0. Right? If I plug in negative 10 into my function, negative 10 squared is 100. 100 minus 9 is 91. Times 2 is 182. 100 minus 4 is 96. So 182 divided by 96, almost 2. It's like 1.8 repeating or something close to that. So 1.88, somewhere in that range, 1.9. If I stick in positive 10, I get the exact same thing. Do I have enough points on the left side and the right side? I would agree. Okay. So now I just got to look in here at negative 1 and at positive 1. If I put negative 1 in there, negative 1 squared is 1, minus 9 is negative 8, times 2 is negative 16. Negative 1 squared is 1, minus 4 is negative 3. Negative 16 divided by negative 3 is 5 1/3. 1, 2, 3, 4, 5 1/3. If I put in positive 1 in there, again I get negative 16 divided by negative 3. So it goes there. So my function goes there. There. And there. Yeah, buddy? Okay. What if we have common factors? By common factors, I mean, let's let's say our function, and I doubt that our function would ever look like this, but you never know. What if our function was 6 over 8? Do I like 6/8? Why not? How can I reduce it? How would I, but how? Divide both top and bottom by 2. Yeah, buddy. What if my function looked like 10x over 15x? Do I like that one? What can I divide both of those by? 5x, right? That leaves me with 2/3. What if my function looked like x plus 3 times x plus 2 over x plus 2 and x minus 2? Those x plus 2's can get rid of. So what does that one become? X plus 3 over x minus 2. What if my function looked like x squared plus 5x plus 6 over x squared minus 4? Get back to the bottom to be what? X plus 2 and x minus 2. What can I factor to the top to be? No. X plus 3 and x plus 2. It's the one that we just did. Yeah. 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 Okay? It's the one we just did. So you factor it first, then you simplify it, then we go forward. You gonna make it? Okay? Right? So the rule of thumb is let's go with purple. What? The rule of thumb is you need to factor or simplify first. Because what that's going to do is that is going to create our next 2 steps. Okay? So, step number 1.5, and I specifically put it in the 1.5 spot. Okay? Which means it comes after you find the domain and the vertical asymptote. Okay? So, we are going to simplify. If something is able to be factored out, that then leads us to step number 5, which is find a whole. Factors, common factors lead to wholes, but it also makes us go back a step and we have to adjust the vertical asymptotes. And I'll show you what this all means here in example number 10. So here is example number 10. Now, I will go back to putting the step number with them for this one. Okay? So, step number 1 says what? Find the domain and the vertical asymptote. What is the domain of this function? what are the vertical asymptotes of that function? Everybody agree with that so far? Okay. Now we have step 1.5. Step 1.5 says we are going to simplify my original function. Can I factor anything out of the top? No, so that's going to stay x minus 2. Can I factor anything out of the bottom? What? Does anything cancel out? It does. What cancels out? The x minus 2's cancel each other out. Okay? So something canceled out. It's called, in the real math, when you go outside of these four walls, it's called a removable discontinuity. Okay? Because why? We just removed something from our function, and now our new function is not continuous. Okay? So a removable discontinuity is just what we did. In here, we call it a hole. Okay? Right? But if you go outside these four walls, it's called a removable discontinuity. Okay? So, because I removed a factor, do I have to adjust my vertical asymptotes? Yeah. Which one goes away? X equals 2 also goes away. I removed that part too. So now, and going forward from this point, my function is now 1 over x plus 2. That's what I use going forward. Yes, ma'am? No. The domain stays. Okay? Because I can't put negative 2 into it because that's where my hole is. Okay? So, now I can put my vertical asymptote on my graph at x equals negative 2. Do I have a horizontal asymptote? Where is it? It's at y equals 0. Degree on the top is 0, degree on the bottom is 1. So that's a y equals 0. Do I have a y-intercept? Zero comma 1/2 is my y-intercept. X-intercept. Numerator equals 0. Did that happen? So do I have an x-intercept? Okay. Oops, I forgot to put my step numbers on there. I told you I was going to put step numbers on there and I forgot. There. Now I went back and I put step numbers on there. So that leads us now to step number 5. Step number 5 says I have to find the whole. Okay? So, the first thing that I am going to do in step number 5 is I am going to set my common factor equal to 0. The common factor in this case was x minus 2. It's what we factored out. Okay? I set that equal to 0. Then, part B says I'm going to solve that. X equals 2. Part C says I'm going to find f of that number that I just solved for in part B. So I need to find f of 2. So if I put 2 into my new function, that's going to be 1 over 2 plus 2. 2 plus 2 is? So my f of 2 is 1/4. Okay. So the whole is at the point 2, comma, 1/4. On my graph now, I go to the point 2, comma, 1/4, and I physically put a circle there. That's my hole. Don't fill in your hole here, Liza. Okay? There's a hole on your graph. Don't fill it in. Okay? It's got to stay a hole. With me so far? Now, we go to step number 7. Step 7 says I got to find some more points to fill in. So, over here, let's go with -3 and -10. If I put -3 into my function, I've got 1 over -1, which is -1. If I put it in -10, I've got 1 over -8, which is -1/8. If I go on this side, let's put in -1, 1 over 1, that's +1. If I put in 10, it's 1 over 12, which is right there. Okay? Now, when you go and draw your function, on this left side, it's all kinds of normal. On the right side, however, you have to physically lift up your writing utensil, jump over your hole, and resume. Do not just straight up fill in your hole. Because now you don't have a hole anymore that you can see. You have to be able to see that hole. Okay? Questions? Ready to try one? Go for it. forward. Domain. All real numbers, but do we agree with x can't be -6 or +1? Okay. Which means my vertical asymptotes are x equals -6 and x equals +1. Yes? Okay. So, now let's factor. My numerator is x plus 6. My denominator factors to be x plus 6 and x minus 1. Agree with that? Yes? So they both have an x plus 6 on them. So, whoop, tap the brakes. Why won't it register? I know, I don't like it. Oh well, stop working. So we lose our color. That's alright. Alright, so we good with there? Okay. Alright, so my new function now, going forward, is going to be f of x equals 1 over x minus 1. Agree with that? Okay. Now I can put on my... Now my colors are all going to be screwed up. I don't like it. Okay, so we're good to go there. Okay, next, what's step 2? Find my horizontal asymptote. What is my horizontal asymptote? Y equals 0. Love it. I'm just going to draw it in. Old school days. Okay. Next, what's my y-intercept? If I plug 0 in there, I get 0, comma, -1. 1 divided by -1 is -1. Okay. X-intercept. None, right? Because I can't have 1 can't equal 0. Right? Do I have a hole? Yes, I have a hole because I had a common factor. So I take x plus 6 and I set it equal to 0. That gives me x equals -6. So my hole is going to be at -6, comma, something. I take that -6 and I put it back into my function. 1 divided by -6 minus 1 is 1 over -7. Okay, so I have to 1, 2, 3, 4, 5, 6. Right there. Do I need any more points on this side, left side of my vertical asymptote? Nope. Okay. Do I need any, but I need some points over on this side, right? So we should try 2.
Yes.
That's going to give me 1 over 1. And we should probably do 10. That's going to give me 1 over 9. Yes? Okay. All right. So my function comes in through here. Then I have to lift up, cross over, finish it off. Comes in up here, and goes like that. Yes, okay. Let's do one more. Go for it. X can equal what? 1 or -5. So that gives me vertical asymptotes at x equals 1 and x equals -5. But if I look at my actual function, I can factor a 4 out of the top. The bottom factors to be x plus 5 and x minus 1. Doubt it's going to work, but we'll try it one more time. Yeah, it didn't work. Yep. The x minus 1s cancel each other out, which also cancels out the x equals 1 vertical asymptote. So my new function from here on out is 4 over x plus 5. 4 over x plus 5, and I'll get this in post. I'll change these on the notes because it's not going to let me. Nope. Has a vertical asymptote at -5, x equals -5. It has a horizontal asymptote at y equals 0. It has a y-intercept at 0, 4/5. It does not have an x-intercept. But now I've got to take that x minus 1, and I've got to set that equal to 0. Gives me x equals +1. Then I need to find f of 1. That's going to be 4 over 1 plus 5, which is 4/6, which reduces to be 2/3. So the whole is at the point 1, 2/3. Plugging in some more points over here. Let's go with -4. If I put -4 in there, I got 4 over +1, which is +4. If I put in 10, I get 4 over 15. If I put in -6, I've got 4 over -1. And if I put in -10, I've got 4 over -5, which is there. So left side, right side. Okay. Tomorrow you have a quiz and you have homework packet 2. Fantastic.